Hello and welcome back to another episode of Ken's Training. Today's training is going to be on an HVAC system. It's a split system. The compressor has mechanical damage. We've already diagnosed it and troubleshooted it, and I'm going to take you through the steps of how I arrived at this conclusion. And we'll get going on that right now. Okay, we're in the UPS room right now. The background noise that you're hearing is from the UPS. So sorry for that. We're not going to shut down the equipment. This isn't a film studio. It's out here in the field, so we got to deal with the background noises that we have to deal with. Behind me is the air conditioning unit. We labeled it number 4. There are four-ton units in the room that we're in right now. The thermostat for this unit is right here. Also, what I have on these units is I have a dual thermometer. And what the dual thermometer does, the air on this unit comes in through the air filter, it comes up through the blower motor, and then through the coil. It goes through the coil, through the blower motor, and then it comes out here into the supply duct. So the air that comes out of here is the supply air temperature, which is the top number. The bottom number is the return air temperature. So there's a probe that I have down here, and it just monitors the air that comes into the unit to tell me what the return air temperature is of the unit. So when I look at this thermometer, I can determine what my differential is. So you want to know if the compressor is running. So that's when you need to come over here and look at the thermostat. So we're going to change the camera angle. Okay, so this is our Ben-Star thermostat. It's telling me that the room temperature is 81 degrees right here by the thermostat. The set point for cooling is at 73 degrees. Now, you see that light right there? It's a green light. That light is telling me that the thermostat is calling for the compressor or the condensing unit to be on. I can tell by my dual thermometer that I don't have cold air, so my next step is to go to the condenser and see what's up. Okay, so here we are. We're at the condensing units now. This is the condenser unit for number 4. Now, I come over, mind you, I've already been here earlier, so I've done some of the troubleshooting before, but I'm going to take you through the steps that I went through. So when I came out here before, everything's quiet. There's no fan motor, no compressor, no nothing. So I know that the thermostat is calling, so I want to see what's going on in the electrical section here. So there's just some tech screws, some 5/16 inch head tech screws that hold on this cover plate. So I pull that off, and then I'm exposed to the electrical. Then you can see the contactor, and I can see the capacitor for the condenser fan motor right here. This particular unit is a 3-phase unit, 460 volt. Now, when I come over here and I look at the contactor, I can see that the contactor is pulled in, and I'll show you that. Okay, so when you're looking at the contactor, this portion right here that's like a little square in the middle, that's an indicator to tell you that the contactor is physically pulled in. Hypothetically, if it wasn't pulled in, I could just take these needle nose pliers, push that in, and then I could push it in by hand. But right now, I can tell you that there's 24 volts going across the coil, which is pulling that in. So then this is pulled in, and you don't have anything going on. The next thing that I want to do is I wanted to investigate the power going to the unit. So we're going to open up the disconnect box. Okay, so now I'm going to open up the disconnect for condenser unit number 4. This is the on-off switch, so by pushing here it's in the off position or the disconnected position. There's a screw here that you need to back off on slowly. back off on in order to open the door. And then there's a little tab right here. I'm wearing eye protection, I got gloves on, and I'm concerned for my personal safety. Opening up this box is going to expose me to live electrical parts. So you want to be knowing what you're doing when you open up this box. You're not just going to go and touch everything with your fingers and then get zapped, electrocuted, and die. So I plan on staying alive after this job, during this job, so I'm going to take some precautions. So I'm going to go ahead and open this up. And you can see here you've got 3 fuses. Now whenever you look at a disconnect switch like this, generally speaking, the way that the electrician wired it in is the power comes in, it goes into the top. This here is usually up like, it fell apart on me. Actually, that plastic just broke. Alright. Usually the electricity comes in, comes down, goes through the fuses, comes out, and then it goes to your condenser or whatever it is that you're servicing. So the first thing I'm going to do is I'm going to go ahead and go to voltage AC. Actually, on my meter, I can leave it in the off position and I have an NCV, non-contact voltage. I can push that in and see if anything is live. So non-invasive to me, I'm touching to make sure that everything is disconnected. Come up here. Okay, I'm starting to get some voltages, but that's just the induced voltage because I'm getting close to live electrical parts. See how the light came on? And you can actually hear that noise. But down here, you're getting nothing, which is telling me that the 3 phases or contact points have all opened properly. Also, I can physically see that they have pulled out, but I'm still going to take it one more step. I'm going to take my meter, I'm going to go to voltage AC, and I'm going to go ahead and just do this. I'm just going to go ahead and go phase to phase. Here's the backlight. Phase to phase, A to B, B to C, and then B to C. And then I'm also going to find a good ground point, which is usually where the conduit touches the box. I'll come up here to a hot leg, which I know to be hot. You can see that that's 280 volts. Now I'm just going to come down here and check it like this. Nothing. Now I'm going to just check the tops. Nothing. So the fuses and everything downstream is safe. I'm live at this point. I'm going to go ahead and do phase to phase over here at the hot point. Got 486 volts on A to B, and this is A to C, 489. So we're completely good on all 3 phases, giving us 480. Now, what you do is you take your meter and you go to continuity. That means when you touch the 2 leads together, it makes a buzzing sound. You can only do this when no voltage is present. I just tested for voltage. No voltage is present on the fuses. So what you do is you just touch one end of the fuse, touch the other end of the fuse. That is what you should be hearing. You should have continuity of the fuse. I got good continuity on the B phase. On the C phase, no continuity. The C phase has a blown fuse. So what I'm going to do is I'm going to take my channel locks and very gently wiggle that out. I've already troubleshot that and I wrote bad on the fuse when I took it out. So that's why it says bad on it right now, because I was here previous to the video and then doing my troubleshooting. Now I've got another 15 amp fuse. Oh, by the way, one way that you can confirm that you've got the correct fuses, this here is the data nameplate for the unit. It tells you right here that the maximum fuse or maximum circuit breaker, HACR type per the NEC, is 15 amps. So I have the correct amperage. And I confirmed that with the data nameplate. I grabbed a 15 amp fuse out of my inventory. I'm going to put my meter on continuity. And I'm just going to touch it like this. Let me do it like this so you can see the meter. Okay, so you go like this. Okay, you can hear that and you can see it. This is a good fuse. It has continuity. So we know that we're good there. So now what I'm going to do is I'm going to put my fuse in here. Everything is still off. I'm live at the top, dead at the bottom. When you put your fuse in, don't put it in upside down. Don't put it in so that the numbers are in the back. And don't disturb the writing that tells you what the fuse is. So I'm just going to take it, put it right side up, facing towards me, put it in like so, and I like to push them in with just a flat-bladed screwdriver. And it just snaps right in, okay? If it did not snap in, I would take my channel locks, pinch that down slightly just to give it a really good tight fit. Now, if I turn that on, I know that I'm going to be producing 3 full phases of electricity to my contactor. My contactor is already pulled in. We already saw that it was pulled in. The question is why did that why did that fuse blow? And at this point in time, I don't know why the fuse has blown. So the next thing I want to do is I want to just do an electrical check on my compressor. We're going to do that right now. Alright, the first thing I'm going to do is I'm just going to observe my electricity. My disconnect is still in the off position. I'll do an NCV. I got no electricity on either side of my contactor. Normally, you feed a contactor from the top down, but I don't know if that's how they did it. So what I do is I follow the disconnect switch, I follow the conduit, and the conduit is this one right here. So this is the conduit coming from the disconnect switch. These lines right here, 1 ground and then 3 power lines are coming in, and they're feeding the bottom of the contactor. So this contactor is fed from the bottom up as opposed to from the top down. So the electricity comes in through the bottom, it goes out through the top, it goes to the condenser fan motor, and the 3 phases go to the compressor. So that's how this whole thing works. But the contactor is pulled in, so I can get on either side of the contactor, but just so I'm on the side going closest to the motor and the condenser fan motor, I'll go on the top of this contactor. I'm going to do an NCV. Nothing is on the top. I'm going to take my meter and I'm going to put it to ohms. There's your backlight right there. Next, if I touch the 2 leads, you'll notice that it goes to pretty much a direct, no ohm reading at all. It's a 1 ohm reading is just the 2 leads touched together. The next thing I want to do is I want to get on a good ground source. So I got some good metal over here. I'm going to touch that metal, and I'm going to touch the metal inside, and I'm going to see what the meter does. Hold on. See how that meter went right to 1. So I'm on a good ground source. I'm going to maintain my right hand on that ground source, taking my left hand, and now I'm going to touch the 3 phases of the top of the contactor, A, B, and C. So here's phase A. It's all good. You know what? One thing that I should mention, that I did this earlier and I forgot to mention that I did this. Before I even touch that, there's a capacitor right here. A capacitor is the one component that can store electricity and it can still kill you. So I shorted this. The electricity is off. I'm just going to take my needle nose pliers while holding the insulated port, the handle, and I'm going to touch against the 2 leads of the contactor like this, which is, if there was any residual voltage stored in this capacitor, that voltage would be dissipated by doing a direct short. So that's how you do that. You just take it and short it out like that. You can also use a screwdriver like this and just touch it like that and just make sure that you've got good clean metal and you're shorting that out. Okay, next. Capacitor is discharged. I'm on ohms. I'm going to make sure I'm on a good ground source. And I am. Now I'm going to touch phases A, B, and C. That's phase A. Nothing is grounded. Phase B. Nothing is grounded. Phase C. Nothing is grounded. Now, I know that my condenser fan motor and my compressor are not grounded. The next thing I want to do is check phase to phase. So I'm going to go phase A to phase B. Right there. 5.1. Phase A to phase C. 3.9. And phase B to phase C. 5.1. Now the reason why I wasn't getting three numbers that were completely equal was because the condenser fan motor is still in there. So what I'm going to do is I'm going to lift up one of the wires that goes to the condenser fan motor, taking that out of the system. So now I have only one wire landed on the condenser fan motor. Let's see if I receive equal readings for the compressor. This is phase A to phase B. 5.1. Phase A to phase C. 4.0. That's not equal. On a three-phase compressor, normally you would get equal readings. A to B, B to C, and then A to C. So let me just do the last one, which is B to C on this one. 5.1. So you'll notice that I did not get equal readings, telling me that the motor kind of tweaked. I'm going to go ahead and land this this wire that I lifted, which goes to the condenser fan motor. Okay, we're going to go ahead and start this unit. Now what happened is we already started this unit up. And what happened is I put on my meter. What I did is I looked at the data nameplate, and I'll show you that right here. Okay. You look at the data nameplate, and you find the compressor is rated at 7.7 RLA. That stands for run load amps. Underneath that is the fan motor, the condenser fan motor. It's 0.7 full load amps. So you take 7.7, you add together 0.7, and you come up with 8.4. So the total amperage that I should get on this is 8.4. So what I did is I took my meter, I put it on amperage AC, which is that setting right there. I opened up my disconnect, I put it on a phase like so, and then while I was standing off to the side, I turned the unit on. When I turned it on, the only thing that came on was the condenser fan motor. And the amperage jumped up high. But the only thing that it was rotating was the condenser fan motor, telling me that the compressor was locked. It was in a locked condition and it was not going to release. So what I did was, with my unit off and verifying that I had no electricity, I took phase B, which is this one, and phase C, which is this one here, and I switched it. Then I put the meter back on, and I threw the disconnect on. And the compressor actually started. When it did that, it sounded like hell. It was a terrible compressor, and I was pulling 4 amps, way low amps. But it was also spinning backwards. On a 3-phase motor, when you change any of the 2 phases, you rotate that motor backwards. So then I stopped the unit, shut it off, make sure I had no electricity. Then I put the phases back to normal, A, B, and C, the correct rotation. And then I'm going to show you what that looks like right now. We'll go ahead and do that demonstration. We'll put our meter on amperage, and we're going to go ahead and start this up. We're going to do that right now. Okay, we're going to turn this unit on, and just to be safe, I'm going to use my left hand. I'm going to kind of distance myself from the disconnect switch, and then I'm going to throw it on. something. I thought I was going to have enough time to actually go through it a little bit better, but apparently not. I wonder if I blew another fuse. So when you want to check your fuses, I'm going to go ahead and I'm disconnected here. I'll do an NCV. It's all dead. I'm going to go ahead and do a continuity check. So when you touch it, you get continuity. This was the fuse that was blown before. Now, all three fuses are good. What I may have done is I may have shorted the internal overload on the compressor. So what I'll do is let me short out that capacitor again. Do an NCV down here, everything's good. Short out that capacitor since I'm going into the unit after I turned it on. Every time you do the disconnect, you need to short that out. I'm going to lift up one wire on the going to the condenser fan motor, and then I'm just going to go ahead and do a ohm reading on the 3 phases. So here, I'm going to put the meter like this so you can see it, and I'm just going to go phase A to B. Hang on, I'm just having a hard time getting in there. Okay, 7.5. This is A to C, 6.1, and then B to C. Now, it must have just mechanically locked up. I didn't give it enough time to blow a 15 amp. I'll try to start it again and see what happens. So I'm going to amperage AC. I'm on one of the phases right there. I'm going to go ahead and go on. We'll try that again. So it's only pulling the amperage of that. I bet you the compressor, if I was to put my hand on the compressor has an internal overload. I am going to guess that the compressor has an internal overload, and that internal overload is opened up. Alright, so basically, either way, I was just trying to demonstrate a compressor with mechanical damage. I don't know if you saw the gauges, but I wasn't seeing any pressures on the gauges. It wasn't giving me normal readings on the gauges at all. So this compressor definitely has some type of internal damage to it. And there's not much I can do except for replace the compressor. So I'll see if I can give you a video on that, but this is the troubleshooting and diagnosing a AC unit that has a bad compressor with internal mechanical damage. And thank you for watching the video.